Hello and welcome back to another video. In this problem, for the limit as x approaches 0 of e to the 2x minus 1 over x is equal to 2, we are asked to illustrate definition 2 by finding values of delta that correspond with epsilon is equal to 0.5 and epsilon is equal to 0.1. So what is definition 2? Well, this is the formal definition of a limit, which states that the limit as x approaches a of a function f of x is equal to L if for every epsilon greater than 0, there is a delta greater than 0 such that if the absolute value of x minus a is greater than 0 and less than delta, then the absolute value of f of x minus L is less than epsilon. So what does this mean? This is basically saying that we need to have, for values that are close to L, values that are close to A for x, there needs to be values that are close to L at a certain level, right? So if you're delta away or less to A, you need to be epsilon away or less to L. So how do we actually show that? Well, we have to dissect what these actual inequalities mean. So here A is 0. So this is just 0 is less than the absolute value of x is less than delta. And here L is 2. So the absolute value of f of x minus 2 is less than epsilon, which we're saying is, first we're doing 0.5. So what does this actually mean? So let's start with this one. If the absolute value of f of x minus 2 is less than 0.5, then it's greater than 0.5 and less than negative, it's less than 0.5 and it's greater than negative 0.5. Therefore, f of x is less than 2.5 and it's greater than 1.5. Again, so this is a range of f of x values that we are needing to stay between for certain x values that we're putting into it. So this is a little bit more confusing of an inequality to solve. But if we ignore this 0 for a second, because the only way that the absolute value of x would not be greater than 0 is if it would be equal to 0, because it can't be negative. So we can basically say that we're looking at this, which would be x is less than delta and greater than negative delta, with the caveat that x is not equal to 0. So we need to find values of x that are between a certain set of values that correspond with f of x being between 1.5 and 2.5. And so I have the graph of f here. And what we can do is see, okay, as this function is approaching 0 on the x-axis, it's approaching 2 on the y-axis, right? And if we're looking between the values of 2.5 and 1.5, we can see that there's a certain distance away from this point here in the middle that you have to get before you leave this valid space of values. And so here, that is an x value of 0.215, and here it's an x value of negative 0.303. So x, to stay within this range, x has to be between 0.215 and negative 0.303. So if this is true, either lambda is equal to 0.215 or negative lambda is equal to negative 0.303, meaning lambda is equal to positive 0.303. And which one of these is it? Well, if we're saying that in one direction, we only have to go 0.215 before we leave, and here we have to go a little bit further, right, 0.303 before we leave, delta here has to be the more restrictive option, because we're saying that if we go a certain distance away, this delta distance, we're going to have only valid values. We're going to stay within this range. But if we go 0.303 in this direction, we're going to leave it, because once we go 0.215, the smaller value, we're going to be leaving these valid values. So we have to pick the smaller value because we know that will stay inside, and therefore we say it's 0.215. And so we do the same with epsilon being 0.1. This will mean that the absolute value of f of x minus 2 is less than 0.1. Negative 0.1 is less than f of x minus 2 is less than positive 0.1. And therefore we're looking at values of f of x that are between 2.1 and 1.9. So going back to our graph, now we need to come up with values, new values that are based off of this, based off of this more restrictive range. So 2.1 drops us to there, 1.9 brings us to there. So now we're dealing with a much smaller range. So now what is the distance that we have to go from this point until we leave the range? So here that's 0.0484, and here that's 0.0517. So for this, x has to be between 0.0484 and negative 0.0517. Is epsilon equal to 0.0517, or is epsilon equal to 0.0484? Like we just said, we have to go with the more restrictive value, because the larger value is going to spit out values when you go in the other direction of the one that it's in that are going to be outside of the range. Therefore, you go with the smaller value, and our two values of delta are 0.215 and 0.0484.